And now it is time to introduce our keynote speaker. He's an author, blogger, speaker, moderator, trainer, analyst. He's an expert on internet, e-business, social web, and the so-called Internet of Things. Born in 1950 in Washington, United States, he has lived in Germany for over 50 years, pursuing a career as a journalist, book author, TV moderator, and public speaker. He's also author of various books, including Digital Transformation, Digital Enlightenment Now, and his latest one, AI Means Business, How to Build a Smarter Company. We are switching now live to Salzburg, Austria. Welcome, Tim Cole.
Johannes, thank you very much for your kind words. Actually, I'm not situated down in Salzburg, but on the other side of the Tauern Massif in the Salzburger Lungau, the coldest region of Austria, where my wife and I moved about 10 years ago. People sometimes call me an internet veteran, or in German, an Internet Urgestein, which gives you a rough idea about how old I am. But I still feel comfortable among the young internet startup set, even though many of them weren't born when I started my blog back in 1995. I'm a compulsive author of books. I have about a dozen of them in the bookshelf behind me here. I've hosted TV shows, I've moderated radio panels, and of course given hundreds of talks like this one, both in person and today, sadly, only virtually. But at least I already have got my COVID shots. So there's hope that we will see each other at some live event in the not all too distant future.
I hope so too. I'm gonna open the stage for you now and for your presentation, Tim. And we're gonna talk afterwards and get some Q&As, okay?
Okay, great.
Thank you so much.
The future of making stuff is closely linked to the rise of artificial intelligence, defined as the capacity given by humans to machines to memorize and learn from experience, to think and create, to speak, to judge, and make decisions. But unfortunately, many people are still afraid of artificial intelligence. They fear that robots will take away their jobs and that new technologies will lead to the total surveillance state. In fact, these fears are justified if we as a society are not careful and let AI fall into the wrong hands. Even those worst nightmares will be surpassed. In my latest book, Success Factor Artificial Intelligence in German, which is also available in English on Amazon as AI Means Business, I try to allay these fears and show how AI can be used by businesses meaningfully and profitably and enriching the lives of everyone. Today, everybody's talking about the smart factory, where everything is automated and the costs of manufacturing are in full fall. But it's important to realize that the smart factory produces one thing above all else, namely information, data, the new crude oil of the 21st century. In this context, it helps to look back on the history of manufacturing. It all began with the first industrial revolution, or what most historians refer to as simply the Industrial Revolution. This was when the primary means of manufacturing moved from manpower to machine power. Fuel sources like steam and coal made machine use more feasible, and the idea of manufacturing with machines quickly spread. They were faster and made all kinds of new innovations and technologies possible as well. The second industrial revolution, sometimes called the technological revolution, brought new sources of power, such as electricity, which led to sophisticated new machines and new methods of making things, such as mass production. Although we usually don't think of the 1950s as the period in which our world turned digital, it was here where the digital revolution began with the first computers. They were often very simple, unwieldy, and huge, large as a room. But they laid the groundwork for everything from punch cards to the internet. So that brings us to Industry 4.0, a term first coined in 2011 at the Hanover Trade Fair by Bosch. It is characterized by a new level of automation where machines can often largely govern themselves, often by using internet technologies or the Internet of Things. Other features of Industry 4.0 include the use of cloud technology and the importance of big data. Today, we stand on the threshold of what some experts are already calling Industry 5.0, or the man-machine revolution. The term refers to people working alongside robots and smart machines. It's about robots helping humans work better and faster. It adds a personal touch to the pillars of Industry 4.0, namely automation and efficiency. Data, as we've already heard, lies at the center of both smart factories and artificial intelligence. Data are increasingly understood as an asset, like machines, buildings, trucks, and cars. Data can take many forms, all of them critical to the success of a company. I remember when Siemens CEO Manfred von Pierer once sighed at a press conference, "If Siemens knew what Siemens knows, our numbers would be better." Some data is digital and therefore easily searchable through databases. Unfortunately, there are other forms of data that, while equally important, aren't available in digital form, or at least not in a searchable one. Things like emails, notes, log files, previous employee data, videos. These constitute what AI people call dark data. Dark data makes up the huge majority of all data in every company, and they're an important gold mine of information just waiting to be extracted and put to use. Some countries are slower than others in realizing just what a treasure chest of data they're sitting on. Sadly, Germany and Austria are generally pretty bad at this, and this is increasingly proving to be a barrier for the adoption of digitalization and AI in these countries. Of course, AI itself isn't really new. In fact, it began back in 1956 at Dartmouth College in New Hampshire, where almost all the leading researchers in a new field called cognitive science gathered for an academic summer camp. They included such luminaries as John McCarthy of Stanford, the guy in the plaid shirt, who invented the term artificial intelligence, and Marvin Lee Minsky, the guy in the knickerbockers at left, who would later go on to found the AI laboratory at MIT. The Dartmouth Workshop, which produced significant breakthroughs in the understanding of AI, sadly also became the first example of the unprecedented hype that was to accompany it ever since. Back in the summer of '56, some predicted that within just one generation, so in about 20 to 25 years, there would be machines that would be as intelligent as humans. Well, as we know now, it was to take almost 40 years, namely until 1997, before IBM's supercomputer Deep Blue would defeat the reigning chess world champion Garry Kasparov and thus claim the title. But this did not stop the AI pioneers from loudly promoting their field of expertise. The result was a series of AI winters in which disillusionment was rampant and investments fell off drastically. Thousands of scientists lost their jobs and migrated to other disciplines or to the private sector. Today, AI is finally poised to fulfill its premature promises and really drive a revolution in everything from manufacturing to R&D, planning, sales, customer services, HR, you name it. AI has continued to make huge advances from simple pattern recognition, which, by the way, is still an important application of AI in business, as we will see, to machine learning, namely self-learning computer systems, and to deep learning, which enables computers maybe not to really think for themselves, but at least to convincingly mimic the functions of the human brain. I need to warn you though, don't expect too much from artificial intelligence, but not too little either. Properly understood and applied, AI can radically transform our economy, our commerce, how we make things, how we communicate with our customers, and pretty much everything else. At the World Economic Forum in 2018, Google's CEO Sundar Pichai said, AI will play a bigger role for humanity than the taming of fire or electricity. Heavy stuff. But back to pattern recognition. Computers are much better at this than we humans are, and we can use this ability in manufacturing, for instance. One of my favorite examples is canned fish. Suppose the operator of a deep sea fishery wants to build a system that helps him distinguish between sea bass, A, and pollock, B, and separate them before they're processed. He might install a camera and record such classes of information as the length of the fish, sea bass are generally slightly longer, or their width, the number and shape of their fins, or the color and luminosity of their scales. This information is fed into a computer that is linked to a sorting robot that distributes the fish to 2 different conveyor belts. Inevitably, mistakes will be made, and a few sea bass will end up with the pollock. But that's bad for the operator because most people tend to think that pollock tastes better than sea bass. Therefore, they're willing to pay more for pure pollock. So the programmer will introduce certain limits. A fish below a certain length, say, will be sorted out, as will those in which the brightness of the scales exceeds or falls below a certain value. However, the system must also take into account the lighting at the location where the picture was taken. Number of information classes and the complexity of the decision-making process quickly rises to the astronomical, and with them, the costs for the operator. Up to this point, we have assumed that the consequences of a wrong decision are always the same. Not so. It is just as undesirable for pollocks to get into a can of sea bass meat as vice versa, but the operator knows from experience that customers are more forgiving if they find a piece of pollock in their can of sea bass. He can adjust the limits for certain classes so that the amount of pollock in the sea bass cans goes up a bit, but the costs go down. At the same time, the plant can work faster because it literally doesn't have to look as closely. The operator can therefore produce more cans of fish at less cost, and his company operates more profitably overall. Pattern recognition may be an old hat, but it is more important than ever in manufacturing today. After all, you can compare more than simply pictures. How about sound? 3D Signals, an Israeli startup, has a system it calls PrediSound, which consists of a number of ultrasonic sensors that can detect slight variations in the sound pattern of, say, heavy machines or commercial vehicles to tell if a failure is about to occur. Samson AG in Frankfurt, a leading manufacturer of control valve technology, has been using PrediSound for more than a year. And CEO Dr. Andreas Wiedel claims his company has been able to increase machine productivity by a whopping 30%. So far, the discussion about AI has mostly focused on dystopian future scenarios, and how AI will transform and improve the economy has not played such a role. In fact, that's a shame because AI can be a real boon for business. Thanks to the analysis of vast amounts of data, the application of complex mathematical models, and the use of self-learning systems, AI researchers can look deep into the future, for example, to identify trade trends or to track and predict the spread of epidemics worldwide, which can not only save hundreds of thousands of lives, but can also protect us from a repeat of the 2020-2021 economic crisis triggered by COVID-19. Thanks to predictive analysis of machine data, companies can protect themselves against failures and downtime in production and detect production errors before they occur, bringing the vision of zero defect manufacturing within reach. Automation will cover more and more industries and areas in which human labor was previously a prerequisite. In return, it will create millions of new jobs where machine intelligence has reached its limits. In its study, The Future of Jobs, the World Economic Forum predicts that AI will destroy about 75 million jobs by 2022. But it will create more than 133 million new jobs over the same time period. Speech recognition, voice control, predictive analysis, learning robots, facial recognition, autonomous vehicles, and intelligent value creation processes are creating new opportunities for companies to take their productivity and competitiveness to a whole new level. AI is the enabler to create three things in particular that will be critical for tomorrow's business. First, satisfied customers. Thanks to AI, companies can learn to understand their customers better. Based on this new knowledge of the customer, they can better predict market trends and better respond to the individual wishes and needs. This leads to more satisfied customers. And satisfied customers, every manager knows, are the best customers. Second, smarter products and services. Gadgets and devices today need to become smarter if customers are to accept them. This applies to the latest generation of cell phones, which are not called smartphones for nothing, just as it does to cars, heating systems, kitchen appliances, televisions, or entire homes. Keyword here is smart home. And finally, autonomous manufacturing. An automation revolution is brewing in industrial production thanks to AI. From autonomous drones to self-controlling delivery robots to self-learning production machines, AI is opening up previously unimaginable potentials on the production line and in the supply chain, making old industries faster, more flexible, and more competitive. The term to remember here is robot process automation, or RPA for short. And please don't be confused by the word robot. RPA is not about more or less human-like machines. Rather, RPA is about software tools that can take on manual, rule-based, and mostly mind-numbing processes, tasks, jobs that humans don't like to do anyway. Also known as enterprise RPA or ERPA, these tools can recognize and create logical paths, enabling them to model a wider range of processes, collect necessary data, and use other tools and systems much like a human would. ERPA provides such helpful features as security and even audit trails. But manual systems too are built on rules, even if they only exist in the minds of the workers and are not formally documented. Virtual robots, also known as robobots, can automatically take over a specific process, often working hand in hand with existing business process automation systems and human operators. According to the Next Generation Process, a study conducted by the consultants at Horvath and Partners, the introduction of RPA is usually based on a four-step model. It starts with simple automation by means of real robots, an important technology because of the large number of routine processes that can be automated using them. RPA software carries out recurring tasks according to clearly defined rules and checks the reliability of the data. It's only in the second stage that the software gets by without predefined processing rules and learns to structure and process rules on its own. Such systems, known as cognitive automation, can read archived documents or emails and categorize unstructured data volumes using digital data training. The more data the software organizes and processes using machine learning, the faster and more effective the system becomes. Cognitive process automation also offers companies the opportunity to extend automation to complex processes, characterized by growing volumes of unstructured information. It can thus understand and derive user behavior from data patterns. It's also capable of automatically recognizing changing framework conditions and adapting the algorithm accordingly. In other words, learning. Most companies lack experience with the third stage of automation, which involves the use of digital assistants. But they're curious. Only 29% of the companies surveyed by Horvath and Partner have worked with digital assistants before, but 75% intend to do so soon. Digital assistants recognize spoken and written language and can understand the information contained in it. They extract relevant data, process it further, and act as a link between people and the system. Think Alexia for the software, for the shop floor. Over time, the assistants learn to independently detect anomalies in the data and can proactively inform their human masters. Cognitive RPA systems can also include advanced analysis and machine learning. They adapt to new circumstances, a crucial difference compared to many traditional IT solutions, which often need to be completely reprogrammed before they can handle new tasks or situations. Digital assistants come in many sizes, shapes, and forms. Their common goal is to enable humans, for instance, by better synchronizing the delivery of parts and resources to the factory. Exoskeletons can be used wherever human labor cannot be sensibly replaced by full automation or by robotic systems. The fourth and highest level of automation is reached when intelligent software can act independently and initiate processes. To date, most Western companies lack almost any experience with such so-called autonomous agent systems. These can make decisions without human intervention and control processes independently. They can process huge amounts of data very quickly, which will make them irreplaceable in the field of predictive analysis. Unfortunately, however, only 2% of companies surveyed already work with such autonomous systems, and another 3% have started testing. This will have to change for many companies if they want to remain internationally competitive in the long term. Robots in factories are nothing new, of course. Traditionally, they work in specially designed areas behind protective fences, cages, so as not to endanger their human colleagues. They manufacture their work pieces as the programmers intended without direct contact with humans. A new generation of robots designed to work directly with humans are sometimes called cobots. KUKA AG, a German robotics specialist now owned by the Chinese Midea Group, use open interfaces to make cobots an integral part of IoT and Industry 4.0 environments. To complement existing mechatronics systems, KUKA uses a cloud-based analysis and intelligence platform called KUKA Connect that harvests data through their fleet of cobots on the shop floor and makes it accessible anytime, anywhere from any device. This, they believe, points toward a future of robot-centric AI and industrial solutions aimed at creating the factory of tomorrow. But let's be honest here, RPA is not a miracle weapon, and it can't solve every business challenge. It is also more complex and requires greater investment of time and talent than typical packaged software, for example. The interactions between bots and cobots must be anticipated and understood. Perhaps that's why so many RPA adopters are large enterprises where the necessary resources and prior technology knowledge exists. However, smaller companies can also benefit from the advantages. There are increasing signs that Microsoft, for example, is planning to add an RPA module to its Dynamics ERP system, which is particularly popular with medium-sized companies. At a recent analyst briefing, CEO Satya Nadella said, quote, "Our platform will combine robotic process automation with self-service analytics and no-code development, enabling our customers to create a more data-centric culture." It'll be interesting to see what will happen if other software giants like Oracle and SAP jump on the bandwagon and take over smaller RPA providers, especially when it comes to the protection of core business processes, where security is both important and, sadly, often neglected by some smaller vendors and their clients. Integration versus build your own could become a key issue here. Whichever way it turns out, it's clear that AI is finally awakening from its winter hibernation and heading for a glorious season of new opportunities and growth. AI may just be the logical next step in automation, the predictable outcome of Industry 4.0, as some say, but while AI will certainly be essential to the future of making, the future will still require human ingenuity. There is no substitute for an intelligent Homo sapiens in dealing with unforeseen and unforeseeable circumstances, or in deciding what to make or whether to make certain things at all. Thank you very much for your attention.
Great presentation, Tim. Thank you so much. Really interesting. We are a little bit running tight on time, but I would like to take one question here from the audience, Tim, and that is, and I read, you often hear that humans differentiate themselves from machine thanks to skills like creativity, empathy, and emotional intelligence, and that therefore these skills should be developed. Should we start teaching particularly these skills in our education system?
Well, if we don't, it will be our own fault if the machines take over. Machines have a huge advantage in routine tasks, in things like we've been discussing here. Humans are very, very good at things that require empathy, creativity, stuff like that. The focus in our education system should be on these skills, teaching our kids how to perform better than robots. This will be essential if we want to continue as a race, as humanity, to be in the driver's seat.
Here I got an interesting one that I would like to take as well. How do you see AI, especially in the HR field? Application robots, job interviews with robots, or would that be an area where it would be better to focus solely on the human factor?
Well, I suppose, again, here it will be a mix of AI and human intervention. AI, of course, can prepare the eventual decision on who to hire. It can.
You mean kind of a pre-selection?
Yes, it can conduct routine interviews. We can do that by machine, video, etc., and extract certain keywords. There's a company in Boston that does a system that they produces of what they call an empathy score. They can tell you if a candidate for a job is actually able to connect with customers and offer real help. This is a new field of HR development, but it will completely revolutionize the field.
Excellent. Unfortunately, we are running out of time. Thank you so much, Tim, for this enlightening keynote. We really appreciate of having you with us today, and we wish you all the best, and hopefully at some point we can see each other face to face and maybe have a cup of coffee together.
Very good. Thank you very much for inviting me.
Thank you.